So another reaction, which is another addition reaction of alkene, is, I'll call this on 1D, is hydration. Hydration. Hydration means what? It means addition of water. So the way it happens in the case of HCl, that is how this one will happen as well. So we are trying to add water across the double bond to form an alcohol, typically in the presence of an acid catalyst. So remember, acid catalyst, and the reaction will also follow Markov-Nikov rule. So we have our RCH double bond and the CH2 reacting with water. I will write the water like this so you will remember, you understand how the reaction goes. You understand how the reaction goes, and then our acid catalyst, you can just write H plus like this. So eventually, we are going to have RCH. RCH, remember, this one has less one hydrogen, and this one has two hydrogen atoms. So it means the OH will come to the first carbon atom, and then we have single bond and CH3. So this is our alcohol. See how it goes. So let's give an example of this. I will still use propene, CH3, CH, double bond CH2, react with water, HOH, that is our water in the presence of acid catalyst. So we are going to have CH3 untouched, CH now, OH, and then CH3. So this is going to be what? Is this propan 1 oil or propan 2 oil? Of course, the oil is on carbon number 2. So this is a propan 2 oil. So let's look at another reaction of alkene, which is oxidation. So oxidation, in this case, we use potassium manganese 7, KMnO4. So this is the oxidizing agent that is going to be used. Remember, oxidation and reduction reaction, don't forget that, loss and gain of electron. So we are adding an oxidizing agent to our alkene. So it means the alkene will act as the reducing agent because it's reacting with an oxidizing agent. So in this case, the oxidizing agent will break the double bond, and then remember, oxidizing agent is introducing oxygen into this to alkene. So we are going to have two OH group across the double bond. Let's see how the reaction goes. We don't need the mechanism of reaction now. So it's going to be RCH double bond CHR prime, our alkene, plus KMnO4. If you like, you can write it this way. You can just put an arrow and then put your KMnO4 on top of the arrow. Same thing. So plus KMnO4, this is going to be, don't forget, they may ask you what is the condition of the KMnO4. It is cold and dilute, because we can use hot conc as well too. But for this reaction, we use cold dilute KMnO4. Remember, it is an acidified KMnO4. Please. Now, our product is going to be, remember, the oxidizing agent is introducing oxygen to this reaction. So I will write it another form. Another way you can write this equation, I'm going to write it after this now. So you will have your RCH, OH, single bond, CHOHR. You may remember I said the OH is adding across the double bonds. So that is why we have the OH here on this carbon and then the OH on the other carbon atom here. So I said I'm writing this equation in another way. You can see it this way. CH double bond CHR prime the arrow, instead of writing the name of the oxidizing agent, they can just write O in square bracket like this. So you can have it this way. So it means oxidation. So we are going to have the same product, RCHOH, and then our CHOHR prime. So that is the reaction. And this reaction can be used to test for the presence of unsaturation. That is, presence of double bond, carbon to carbon double bond, or carbon to carbon triple bond. You can use it. Remember the color of potassium manganese 7, it is purple. When you add it, or you pass the what do you call you pass the gas, if your alkane is a gas, you just react both of them together. Actually, the color, the purple color of KMNO4 will disappear. That is, the solution, the color solution will be decolorized. So it means you have a double bond, carbon to carbon double bond before, that is unsaturation. It's able to react with the KMNO4 to become saturated. So when it becomes saturated, then it's your product is colorless because you didn't have KMNO4 in the solution already. It has already reacted to your alkene. That is why the color disappears. If it is an alkene, that is carbon to carbon single bond compound, there will be no reaction. So if there's no reaction, it means the purple color of KMNO4 will remain because it does not react. You still have it in the solution. But when it reacts, it becomes something else. That is why we don't see the purple color again in the case of reaction with alkene. But in the case of reaction with alkane, the purple color will persist because there is no reaction. The last equation or the last property or the last reaction of alkene we will look at is polymerization. So alkene can link together. They can link together to form long chains called polymers. So this is how plastic like polythene or polypropylene, that is how they are formed, or this is how they are made, by linking together, linking alkene chain together to become a long chain, a giant molecule called a polymer. So it means we have, I will use ethane as an example in this case. That is what they use majorly. So we have ethane, which is C2H2, is our ethane. You have many of them. So N's, this N. You will see N in front of it like this. N means a number of CH2 double bond CH, that is a number of C2H4. So they undergo a reaction, polymerization reaction, in the presence of catalyst, heat, and pressure. So you need to add them. So you are going to have your CH2, single bond CH2, and then you have to show that the bond extend across the bracket like this. That shows that this chain continues, and then you have a number of this. N, see where we put N here, and then look at where the N is put here. Don't forget. So this is our ethene as our starting material, and then the product is many ethene, which is a polyethene or polythene, any way you want to write it. So that is the last reaction of alkanes. So we have looked at the way of making alkanes down to their properties. We look at their chemical, their physical properties first, and then we look at their chemical properties. If you go back to the beginning of the reaction, we started with the properties, with the So if you want to summarize everything we learned today regarding the alkenes, we started with the general molecular formula, that is CnH2n, and also the functional group, which is carbon to carbon double bond. We talked about that the double bond is because of the presence of pi bond electron, and then we're trying to generate a molecule from the general molecular formula. We said the smallest number of carbon chain of carbon in an alkene is going to be 2. So you cannot have n equals 1. You only have n equals 2 to give you the smallest family of alkene. We said the geometry is planar because the two hydrogen atoms that bond to each carbon atom, they appear like they make the shape of the molecule like a plane geometry. And then we look at the way of making alkene. We started by looking at dehydration of alcohol, and then we talk about halogenation of alkyl halide. Another one is partial hydrogenation of alkyne. Then we move to the properties. We look at the uh, reactions of alkene. The first one is hydrogenation. We look at halogenation reaction with halogen. Then we look at hydrohalogenation reaction with alkyl halide. So reaction with hydrogen halide like HCl, HBr, HI. And then we look at hydration reaction with water. We said everything when we're talking about addition reaction, we are breaking the double bond, and then anything that is coming, they are adding across the double bond. One to the first carbon atom that bond to the double bond, the other one to the next carbon atom that bond to the double bond. We look at oxidation reaction as well. We talk majorly about Markovnikov rule here when you are adding hydrogen halide or you are adding water to your alkene. We said hydrogen atom will go to the carbon that has more hydrogen atom already, and then the other molecule or the other atom will go to the next carbon that have the less number of hydrogen. And that is why X is added to CHR here, and then H is added to the CH2 here. Same thing in the case of water in hydration down here. Don't forget about the catalyst that is used in the reaction. We go to oxidation and finally polymerization reaction. Thank you so much. We will meet again where we will talk about the next hydrocarbon, which is the alkyne. Bye-bye.